Hey there, Mr. Chu here, wearing a hat. And yes, I've told many of my students I do wear hats. When I'm not teaching at school, wearing a Larry Bird shirt as well. It's a hoodie. So let's get started in this video of geometry topics for the proof chapter. Let's talk about conditional statements. So I am Mr. Chu. I do lots of videos, and I am a geometry teacher. This video follows a handout for a Period 4A geometry class that I'm teaching that is linked to an assignment in Infinite Campus. It's been attached in an email also so that students can see it if they've lost their copy or if they left it at school. For those watching who are not in the class, you can learn about if-then statements while watching the examples in this video. Feel free to pause the video when necessary to write down your examples, or if you're writing down vocabulary, let's learn about conditional statements. So, in our textbook that we're using in class, it's page 107, if you'd like to refer to that, if you're the students. If not, just pay attention, because the students are going to learn how to analyze statements in if-then form, to write a converse, inverse, and contrapositive of if-then statements. So in the textbook, this is Chapter 2, Section 3. If-then statements are conditional statements which can be written in if-then form. The direction given below is an example of a conditional statement. If you would like to speak to a representative, then you will press 0 now. So there's certain things that you can identify and use. Let's talk about some of those now. So here is a key concept conditional statement chart. An if-then statement is of the form if P then Q. P and Q happen to be statements. We can write it in symbols, P with an arrow Q, and you read that if P then Q or P implies Q. And here's a model that shows them. Another vocab, the hypothesis of a conditional statement is the phrase immediately following the word if. So, in our example up here, you would like to speak to a representative is the hypothesis. The next vocab, the conclusion of a conditional statement, is the phrase immediately following the word then. So, you will press 0 now. So, it's several words after that. So, the beginning is the hypothesis, and then the conclusion is after the then. When a conditional statement is written as an if-then statement, you can quickly identify its hypothesis and conclusion. So in example 1 from the book on that page 107, it says identify the hypothesis and conclusion of each conditional statement below. And I want you to be able to do that. You can refer to the book or just look up here on the screen. If the forecast is rain, then I will take an umbrella. The hypothesis is after the if. The forecast is rain. The conclusion is the words after the then. I will take an umbrella. Example 1b. A number is divisible by 10 if its last digit is a 0. The hypothesis would be the last digit of a number is 0. Now see, this is kind of tricky because that's a part that's after the if. And then the conclusion will be the number is divisible by 10. So sometimes you have to rewrite the statement in if-then form, the conditional statement. And I would rewrite it, if a number's last digit is 0, then the number is divisible by 10. And that would be the way that you could rewrite that. All right, I'll just move my little picture around as needed. So, from the worksheet that was handed out, there's another little chart here about if-then statements with a couple more examples to try to make more sense of it. If-then statements, such as, if you're reading this page, then you are studying math. A statement that can be written in if-then form is called a conditional statement. That's just to review that vocab. The phrase immediately following the word if is the hypothesis, and the phrase immediately following the word then is the conclusion. A conditional statement can be represented with symbols P and Q with that little arrow, which is read P implies Q, or if P then Q. So here's another example. Let's talk a little geometry. Identify the hypothesis and conclusion of the conditional statement. If angle X is congruent to angle R, and angle R is congruent to angle S, then angle X is congruent to angle S. So we have the hypothesis underlined here, the conclusion here after the then. This looks a lot like the transitive property from algebra. All these things are related. Example 2, identify the hypothesis and conclusion. Write the statement in if-then form. You receive a free pizza with 12 coupons. If you have or receive 12 coupons, then you will be able to get a free pizza. The hypothesis, you have 12 coupons. The conclusion, you receive free pizza. All right. So as we continue now, we will look at this particular related conditional definition from the book. And this is from page 109. There are other statements that are based on a given conditional statement. These are known as related conditionals. So of the related conditionals, we're going to talk about 3 more. The conditional statement is a statement that can be written in the form if P then Q that we write. Symbols like this. Here's an example. If the measure of angle A is 35, then angle A is an acute angle. We knew this from what we did in chapter 1. Another related conditional is the converse. So here's another vocab. The converse is formed by exchanging the hypothesis and the conclusion of the conditional. All you do is flip them. So we started out, if P then Q, now we're going to say if Q then P. So in this example, we're going to take and start out with the hypothesis by using the conclusion. If angle A is an acute angle, then we have the original hypothesis as our conclusion. The measure of angle A is 35. So we just switched them. That's called a converse, and you'll be asked to write some of those in our examples shortly. The inverse is formed by negating both the hypothesis and the conclusion of the conditional. Now, if you remember from an earlier section in this chapter, when I have that little tilde, which is that little curved mark in front of a P, that means not P. And that little tilde in front of the Q means not Q. So we'd read that, if not P, then not Q. So in our example, the same example, we look at our original and we just put a not right after the is and a not right after the is. If the measure of angle A is not 35, then angle A is not an acute angle. The last related conditional is a contrapositive. Here's the vocab meaning. The contrapositive is formed by negating both the hypothesis and the conclusion of the converse of the conditional. So now I take the converse, which means I flipped. Not Q, then if not Q, then not P. So I go up here to my converse and I say, I'm going to put a not and the is here and here. So if angle A is not an acute angle, then the measure of angle A is not 35. So the converse, inverse, and contrapositive are going to be important as we continue to study geometry. So now, if I say you receive a free pizza with 12 coupons, that's just a repeated. Let's look at our exercises now. That's what we want to do. So it says, I'm just going to totally move my face off the screen for a second. Write the converse, inverse, and contrapositive of each true conditional statement. Determine whether each related conditional is true or false. If a statement is false, find the counterexample. You can write this down if you'd happen to have the worksheet. Then you would be able to follow along. If you live in San Diego, then you live in California. Is that true or is that false? That is a true statement. It says, if false, state a counterexample. Well, there's no need to state a counterexample because it's not false. What would the converse be of this? Remember what we're doing with the converse now. You're flipping them. So you flip the hypothesis and the conclusion. So you say, if you live in California, then you live in, and it should be San Diego. That's a typo. That's false, because you could live in Sacramento, right? Doesn't mean you have to live in San Diego. Now let's do the inverse. You remember what the inverse is? We're going to say a not live in the places. So if you don't live in San Diego, we're doing our original, not San Diego, then you don't live in California. That would be false. That's not always true, because you could live somewhere else in California. Remember, the contrapositive is taking the converse and negating them. If you don't live in California, then you don't live in San Diego would be true. Example 2. If a polygon is a rectangle, then it is a square. Is that true or is that false? That's false. Counterexample is when you're going to say, why is that false? Well, remember what's true about a rectangle. It's got a length and a width, right? But in a square, you have all the same side lengths. So since they can be different in a rectangle, it's not necessarily going to be a square. So that is a counterexample. Converse, remember what you're doing. You're just flipping the hypothesis and the conclusion. So you'd say, if the polygon is a square, then it is a rectangle. That also is false. On the inverse, remember, we're saying not to our original. If a polygon is not a rectangle, then it is not a square. That is true. And the contrapositive is when you take that converse and negate that. If the polygon is not a square, then it's not a rectangle. That is also false. All right, you can list counterexamples of each of those. Number 3, if the two angles are complementary, then the sum of their measures is 90. True or false? That happens to be true. Move my face back on here. So, since it's true, we don't list a counterexample for that one. Remember the converse, we're flipping the hypothesis and the conclusion. If the sum of the measures of two angles is 90, then the two angles are complementary. That is true. Now, an inverse, we're going to say not to the original. If two angles are not complementary, then the sum of the measures is not 90. That's true. Now, the contrapositive, we're going to negate the converse. If the sum of the measures of two angles is not 90, then they are not complementary, and that as well is true. I'll go off the screen now when we start these other examples. Identify the hypothesis and conclusion of each conditional statement. If it is Saturday, then there is no school. So the hypothesis just follows the if, it is Saturday. The conclusion follows the end, there is no school. Number 2, x minus 8 equals 32, then x equals 40. And we know that's going to be a true statement. It's just basic algebra. The hypothesis follows the if, x minus 8 equals 32. The conclusion follows the then, x equals 40. Number 3, if a polygon has 4 right angles, then the polygon is a rectangle. The hypothesis follows the if. A polygon has 4 right angles. The conclusion follows then. The polygon is a rectangle. Write each statement in if-then form. All apes love bananas. Now, you can modify this a little bit. The way I wrote it is, if the animal is an ape, it loves bananas. You could identify the hypothesis and the conclusion. Then you could determine if that's true or not. Number 5, the sum of the measures of complementary angles is 90. Just reviewing things we did in chapter 1. So in if-then form, if the angles are complementary angles, then the sum of their measures is 40. And there is misspelled. There is another typo, Mr. Chu, hurrying up the lesson. Number 6, collinear points lie on the same line. So in if-then form, if points are collinear, then they lie in the same line. The hypothesis, points are collinear. The conclusion, they lie on the same line. Number 7, if today is Wednesday, then yesterday was Friday. If true, explain. We're to determine the truth value of each conditional statement. If true, explain your reasoning. If false, give a counterexample. So if today is Wednesday, then yesterday was Friday. That is false. Why? Here's a counterexample. If today is Wednesday, then yesterday was Tuesday. Number 8, and the last example, if A is positive, then 10 times A, or 10A, is greater than A. If true, explain. If false, give a counterexample. Well, in that case, it is true, because 10 times a positive number is going to be greater than the original number. All right. Now, Mr. Chu's Period 4A geometry students can complete that worksheet. And there were, I think it was 9 problems that you can complete and turn in when you come back to class. Remember, it's attached in Infinite Campus, and it was emailed to everyone earlier. And remember the important thing about all of my videos. I'm Mr. Chu, and I want to help you understand geometry. Subscribe to my YouTube channel and you can see lots of other videos. I look forward to seeing you in the next one. Have a great day.